Functions. So we have a very important concept here, the function. It's one of the most important things in the subject that we're studying, and we define a function. It's a type of relation. So functions are all relations, but the vice versa does not apply. So all functions are relations, but not all relations are functions. A relation is a function if for each x value there is only one corresponding y value. That's very important. Now, x values are independent. Okay, so they're part of the independent variable or the independent set. We'll talk more about that in a minute. And y values are dependent. There'll be more about that in a later video. Independent change by themselves, or if it's an experiment, perhaps the human running the experiment can change the independent variables or the independent quantities. The dependent are changed as a result. Again, more about that in a later video. If we just stick with x and y values then, for now, so each x value can only have one y value. So basically, in other words, a function cannot have two different ordered pairs with the same first coordinate. Let's write down some examples. So if we've got a function which produces these ordered pairs, okay, we'd call that one x and that one y. Now, because it's the first point, it's x1, y1. We have another point. Three, 4. Call that x2, y2. These are little subscripts. They're just naming devices, subscripts. And 4, 5. That'll be called x3, y3. And we check that each x value can only have one y value. Well, the x values are 2, 3, and 4, and the y values are 3, 4, and 5. So yeah, every x value has a different y value, and we might be able to come up with a rule for that one. Y equals x plus 1 would be a suitable rule for that function. So let's look at another example. So negative 1, 1. 0, 0. And 1, 1. Let's check if that could be a function. So every x value has to have a different y value. So let's have a look. Well, yeah, this x value's got negative 1, and the y value is positive 1, 0, 0. And now what about this last one, 1, 1? Well, every x value has a different y value. So it is still true, it is still a function. It's easy to see that because all the x values are different, so we don't have to really worry. And possible rule for that, we could write, let's see, what about y equals x squared? That would work, wouldn't it? So that's fine. And what about another one, another example? What if we have these ordered pairs? 2, 3, 4, 1, 4, 2. There's a problem with this one, isn't there? every x value does not have a different y value. We have 4 here and here. 4's got the y value 1 there and 2 there. There is a problem. Thus, out of those 3 examples, the first one and the second one were functions. The third one is only a relation. It is not a function because x has 2 y values, so it can be called a relation but not a function. And if we plotted those points, we would find with the third one, put it on a simple little graph, we'd find that, okay, if we have 1, 2, 1, 2, 3, this is very rough, but the first point would be there, 4, 1 would be there, and 4, 2 would be there. You can see that those last 2 points were straight on top of each other. Now that graphically is a way of showing what we found there through the textual definition. It's called the vertical line test, which we'll talk about very soon. It's a way of testing whether something is a function or not. So we'll make a link to that very soon. So next is an interactive part of the video. I want you to pause the video and do these 2 questions here. Which of the following sets of ordered pairs defines a function? And make sure you've got a reason why. So pause the video, do the quiz, and then unpause the video. Now that you've had a chance to write your answers down, and they should go in your notes, your answers to the quiz, let's have a look at the answers. For the first one, every x value is different, and that's fine. It is a function because it suits the definition. So every x value has a different y value. So every x value has a different corresponding y value. What about the next one, part B? If we have a closer look, it is not a function. So x value of -4 has 2 different y values there. So -4 is mapped onto 1, but it's also mapped onto -1. That means it's only a relation and it's not a function. Same here, -6 maps onto both 7 and 8. So there's 2 reasons, and so you'd write your answer down. It's pretty much not in front of the statement above, and you could write down, e.g., 4 maps onto both 1 and -4 maps onto both 1 and -1, and ditto with the 6's, so you'd write that down as well. Okay, so it is the case of the first one was a function and the second one not a function. Both are relations, however. So let's have a look at a couple more examples here, which are pasted in below. Question is, y equals x squared a function? And then state what's called the maximal domain and range of y equals x squared. Okay, well, y equals x squared is a function because for each, there's a few ways of doing it. You could create a table of values and look at the ordered pairs, and you would see that every value of x has a different value of y. So that statement there is consistent with the definition of a function. In other words, they'd be all in that form. No matter what, looking at the function y equals x squared, no matter what the first number is, the second number will be a square of it. So they're all going to be different. You can see below it talks about the vertical line test. Very important to note the following. The vertical line test, as I mentioned before, is a way of testing graphically whether something is a function or not. So whether a relation is a function or not. And please make note of the following. Basically, if you have the graph of a function available, if you put in a vertical line at any point, it must only cut the line of the function once, because you can plot a function. Functions can be written as ordered pairs, they can also be graphed, and so if you put a vertical line anywhere in the function, it will only ever cut through once. Alright, so if it cuts through at most once for any vertical line, it is a function. The rest of the question state the maximal domain and range. So this idea will be covered more fully in a later video, but basically the maximal domain are all real numbers. So real numbers are all numbers we come across in the subject math methods. It's only in specialist maths that we go beyond that and look at complex numbers. You don't have to worry about that. It's pretty much any number you can put on a number line is a real number, hence that boldface R there. And so maximal domain is when we're not 100% sure, but it would be reasonable to assume that the domain would be all real numbers. So the range, if the domain is all real numbers, so in other words, you could plot this function forever to the left, alright, and it would extend out like that, and you could also plot it forever for any value you like in the positive direction. It would just keep going. Thus, if it's going to keep going left and right, for the range, which is all the possible y values, it will just keep going up and up and up, and so both ends of the graph will just keep going up and up, and that's why the range is from 0 to infinity. You can see that this graph turns around at y equals 0 and it keeps going on to infinity. Remember, we got the curvy brackets there, can't include infinity, it does include 0, so we've got the square brackets on the left. The last example was, is x squared plus y squared equal 4 a function? And basically, as I might have mentioned in the past, that is the formula that will produce a circle if you plot it, and you're not expected to know that at this stage, but I'm helping you out by letting you know. And basically the form is x squared plus y squared equals r squared, where r is the radius. So that would be, in this case, 2 squared, so the radius is 2. So that will produce a circle with the center at 0, 0, at the origin in other words, and it will have a radius of 2. So it cuts at 2 there, and negative 2 there, and 2 there, and y equals negative 2 there. So it's not, because of the vertical line test, it is not a function. It cuts twice. You can put a vertical line in several spots, and if it cuts twice at any stage, that disqualifies it from being a function. So it's only a relation, it's not a function. The domain is all possible x values, and it's pretty obvious that it's from negative 2 to 2 inclusive. So is the range, all the possible y values from negative 2 to 2. If there are any